Have you ever wondered what would happen if a dinosaur that once ruled the Earth suddenly appeared in the modern world? I'm not talking about T-Rex, but the Spinosaurus, a semi-aquatic predator considered one of the largest carnivores to ever exist. Reaching lengths of about 45 to 50 feet, weighing an estimated 6.5 to 9 tons, and equipped with a massive paddle-like tail, paleontologists believe this beast spent most of its time hunting underwater. Because of this, if you had to pick one place on Earth today that closely resembles its habitat from over 95 million years ago, many would immediately think of the Florida Everglades. But the Everglades is not some unclaimed wilderness. It is a massive wetland ecosystem spanning over 2,300 square miles, home to hundreds of species of fish, waterfowl, American alligators, bull sharks, turtles, deer, and even the invasive Burmese python. Each species occupies its own niche in the food chain, creating a balance that has been thousands of years in the making. So if a prehistoric apex predator were to suddenly emerge, would it become the new king of the swamp? Or would it be rejected by the modern ecosystem? So how long do you think a Spinosaurus would survive in the Everglades? A week, a year, or perhaps decades? Take a guess before we dive in, because the answer might be very different from what you'd expect. The story begins in mid-August, as Florida enters its most intense hurricane season of the year. Rain pours down in sheets, with wind gusts exceeding 90 miles per hour, causing the water in the canals and marshes to rise rapidly. Amidst the mud on a small hummock rising from the floodwaters, a giant egg begins to shake. Just minutes later, the shell cracks open, revealing a newborn Spinosaurus. Challenges arise from the very first moment. The floodwaters sweep the hatchling away from its nest before it can even find its footing. For most animals, this would be a death sentence. However, the ancestors of the Spinosaurus lived in the massive river systems of ancient North Africa, where the rainy season regularly triggered violent floods. Millions of years of evolution provided them with webbed feet, a powerful tail, and the ability to maintain balance underwater. It was these very traits that allowed the hatchling to cling to a cypress tree, stubbornly fighting for hours until the storm passed. Surviving the first day didn't mean things were going to get any easier. On the contrary, the real challenge had only just begun. 3 days passed, and it still hadn't caught a single thing. A Spinosaurus hatchling, only about 3 feet long, still required a significant amount of food to sustain its rapid growth. In the ancestral environment of its kin, the rivers were teeming with giant fish like Mawsonia or other species far larger than the hatchling itself. A single, precise strike would have been enough to secure a meal. The Everglades, however, was a completely different story. The fish here were smaller, faster, and well accustomed to evading local predators. The Spinosaurus failed repeatedly as it tried to snatch bass gar or freshwater turtles. Driven by hunger, its survival instinct kicked in, and it even tried to chew on marsh grass, but the digestive system of a carnivore simply couldn't process plant matter. Only minutes later, it was forced to regurgitate everything it had swallowed. Finally, luck struck when it stumbled upon a rotting fish carcass, leftovers from an alligator's meal. It was the first bit of food that kept it alive. But in that moment, the Spinosaurus learned the first rule of the Everglades. If you see a carcass, the creature that killed it is likely still lurking nearby. Unlike most other shark species, bull sharks can live and hunt in fresh water. They are notorious for their aggressive nature and often use test bites to determine if prey is worth attacking further. The shark clamped its jaws onto the Spinosaurus's tail and quickly backed off. The pain sent the hatchling into a panic. It scrambled toward the shallows where the shark's massive body was no longer an advantage. As the opponent closed in again, the Spinosaurus instinctively slashed its sharp claws forward, striking the shark right on the snout, a highly sensitive area. The surprise counterattack forced the predator to retreat. That was the Spinosaurus's first victory against a real adversary. However, the wound on its tail would leave a permanent scar, serving as a reminder of the second lesson: even in the water, which was supposed to be its greatest advantage, it was never truly safe. As time passed, the Spinosaurus grew rapidly. After about 6 months, it was nearly 10 feet long and weighed several hundred pounds. Its fishing strikes became more precise, and its swimming speed far exceeded what it had as a hatchling. It gradually learned which areas held the most fish, where alligators usually ambushed their prey, and when to steer clear of deep water. However, the Everglades was about to enter its toughest challenge of the year. The dry season arrived, causing the water levels to drop day by day. Wide canals began to shrink, and many marshy areas dried up completely. Fish turtles and other aquatic life were forced to concentrate in the remaining water holes. For alligators, wading birds, and every other predator in the region, this was a golden opportunity. But for an animal as dependent on deep water as the Spinosaurus, it was a sign of a looming crisis. Days of failing to find enough food left it noticeably weakened. When it finally discovered a large water hole teeming with fish, only to find it occupied by 3 American alligators, the Spinosaurus had to make the most critical decision of its life: continue starving or fight to secure its survival. If you were the Spinosaurus in that situation, would you choose to retreat or take the risk? Its decision would not only determine its own fate, but also mark the moment a prehistoric predator began to completely reshape the order of the Everglades ecosystem. In just over 2 years, the Spinosaurus had become the most feared creature in the entire Everglades. This colossal hunting machine was now unrivaled, with almost no other animal capable of standing up to it. Even the Burmese pythons, once considered the invasive apex predators of the swamp, began to disappear from the heart of the wetlands. On the surface, this looked like a total victory, but nature doesn't operate like a prize fight, where simply defeating an opponent is enough. In the wild, every living thing depends on a complex food web. When one link grows beyond its limits, the entire system begins to lose its balance. Imagine an adult Spinosaurus needing about 90 to 130 pounds of meat every day to sustain its body. That means in a single year, it could consume over 16 tons of animal biomass. It is a staggering number for an ecosystem like the Everglades, where most animals are small to medium-sized, and large prey are few and far between. At first, the population of large fish plummeted. Areas that once teemed with life became barren within just a few months due to relentless predation. As fish grew scarce, the Spinosaurus turned its sights to freshwater turtles, waterfowl, and even white-tailed deer. This inadvertently triggered a chain reaction. With fewer waterfowl, populations of insects and aquatic creatures exploded, spiraling out of control. As deer shifted their migration routes, the seeds of many plant species were no longer being dispersed as they once were. Meanwhile, alligators lost their traditional food sources, forced to compete with a far more formidable rival. Ecologists call this phenomenon a trophic cascade, where a shift at the top of the food chain ripples down through every level below it. The arrival of a single new predator can fundamentally alter the entire structure of an ecosystem for years to come. Many might look at this and think the Spinosaurus had become the new king of the Everglades. But is being king in a land rapidly running out of resources truly a victory? As the prey population dwindled, the first problem wasn't the battles, it was the distance. In the past, the Spinosaurus only needed to travel a few miles to find a meal. Now it had to swim dozens of miles along the canals, venturing out into estuaries and even hugging the coastline in search of large fish. Each hunt dragged on longer, which meant its energy expenditure skyrocketed. It is a common paradox in biology. The larger you are, the more energy you need to survive. An animal weighing several tons doesn't just burn through energy while hunting. It consumes calories even while swimming, moving, and resting. If the caloric intake falls below what is being burned for weeks on end, the body begins to break down its own fat stores and eventually its muscle tissue. compensate for the lack of food, the Spinosaurus expanded its territory. If its hunting range was once just a few dozen square miles, it now had to patrol an area many times that size. However, expanding its territory also meant spending more time on the move instead of resting. Another paradox emerged: the further it traveled to hunt, the more energy it burned. The more energy it burned, the more it needed to hunt. And so that vicious cycle continued to repeat itself. The Spinosaurus's dominance didn't crumble because of an enemy, but because of the harsh law of survival itself. When a creature exceeds the limits of its environment, it ultimately triggers its own downfall. So if science were one day to truly resurrect a dinosaur like the Spinosaurus, do you think we should release it back into the wild? Or is the wisest choice to let those giants remain in the past, where nature originally created them to belong? If even one link is incompatible, the entire system pays the price. Perhaps the greatest lesson from this hypothesis isn't about how powerful the Spinosaurus was, but that raw power can never replace balance. Even a perfect predator will fail if the environment cannot sustain it. So if science were one day to truly resurrect a dinosaur like the Spinosaurus, do you think we should release it back into the wild? Or is the wisest choice to let those giants remain in the past, where nature originally created them to belong? Imagine being the most powerful predator on Earth. You're hungry, and right in front of you sits 8 tons of slow-moving meat. It looks like an easy meal, and yet you choose to walk away. Not because you are weak, not because you are afraid. But because in the wild, even a single, serious injury can take away your ability to hunt. And that alone can decide whether you survive. For decades, paleontologists have studied fossils from the late Cretaceous. They have found clear evidence of Tyrannosaurus rex feeding on many different animals, including Stegosaurus, Edmontosaurus, and Triceratops. There are bite marks, broken bones, and signs of violent encounters. However, there was one dinosaur that was truly extraordinary. Even though it lived right in the heart of T-Rex territory, scientists have never found a single bite mark from the tyrant king on its body. So what exactly was this prehistoric creature? The one that could make even T-Rex pause and think twice before attacking. To understand this animal, we have to go back to the early 20th century. In 1906, in the Badlands of Hell Creek, Montana, fossil hunter Barnum Brown uncovered something unusual. At first, it did not look like any dinosaur scientists had seen before. The bones were broad, low to the ground, and covered with strange, bony plates. This was not a fast runner. It was not built for chasing. It was something entirely different. The animal would later be named Ankylosaurus magniventris. The name means fused lizard with a great belly, a reference to its wide, heavy body and the way its bones seemed almost locked together into a solid structure. As more fossils were studied, a clearer picture began to emerge. Ankylosaurus measured roughly 20 to 26 feet in length. It could weigh between about 5.3 and 8.8 tons. That made it heavier than many of the large plant eaters it lived alongside, including some individuals of Triceratops. And today, it is considered the largest known member of the ankylosaur family. But its size alone does not explain why predators avoided it. Because the real story wasn't about this prehistoric creature's size. It is about how it was built to survive. What truly set this animal apart was not just its size. It was what it carried behind it. At the end of its tail was a massive, bony club. In large adults, this club could reach about 22 inches across. It weighed close to 50 pounds. And it was not just for display. Studies suggest that a full swing could deliver between 7,000 and 14,000 newtons of force. That is enough to cause serious injury to bone, especially to the legs of a large predator. Now imagine the encounter. A Tyrannosaurus Rex moves in. Slow, careful. It tries to approach from behind. But Ankylosaurus does not run. It pivots, keeps its tail facing the threat, and in a fraction of a second, it swings. A direct hit to the hip and the lower leg. For a predator, that kind of injury is dangerous. Not because it kills immediately, because it could strip the T-Rex of its ability to hunt. And here is what makes this even more interesting. What looked like an easy meal has now become a calculated risk. Despite decades of research, scientists have not found confirmed bite marks from T-Rex on adult Ankylosaurus fossils. That absence does not prove it was never attacked, but it does suggest something important. Encounters like this may have been rare, or simply, it wasn't worth the risk for a T-Rex. But the story does not end there, because this powerful weapon may not have evolved only for defense. In 2022, researchers studying a close relative called Zool cruravastator found something unexpected. Several specimens showed healed injuries along the ribs and flanks. The damage matched the shape and force of a tail club strike from another ankylosaur. Which leads to a different picture. This weapon was not only used against predators, it may have been used against rivals of the same species, for territory, for dominance, or for access to mates. The answer still lacks definitive evidence. But one thing can be confirmed. The most powerful weapon this animal possessed was not just a shield against danger. It was also a part of its own internal struggle for survival. And if two adults faced each other, both carrying that same weapon, the result would not be subtle. It would be force against force, measured, deliberate, and potentially devastating. That was when they were young. A juvenile Ankylosaurus magnaventris did not look like the armored giant we imagine. Its body was smaller, its armor was thinner. And the tail club, the very weapon that made adults so formidable, was not yet fully developed. At this stage, it was vulnerable. In the world of Hell Creek, that vulnerability did not go unnoticed. Smaller predators, including dromaeosaurs and other theropods, would have seen an opportunity. They likely targeted the young, using speed and coordination to isolate individuals from the group. A brief moment of separation could be enough for a fast-moving hunter to strike. Even crocodile-like animals living along rivers and floodplains could pose a threat to a young ankylosaur. Young ankylosaurus individuals could not survive alone. They may have stayed close to one another, or within the presence of larger, more developed individuals. Not because they were strong, but because staying together reduced the chance of being singled out. For a time, survival was not about strength. And this reveals something deeper about even the most powerful animals. For a part of their lives, they exist in a completely different world. A world where they are not protected, not dominant, but exposed. Because for a time, even the strongest species begins in weakness. That phase does not last forever. As Ankylosaurus grew, its armor thickened, its body became heavier, and its tail transformed into the weapon we have already seen. Eventually, it reached a point where it no longer needed protection from others. Adults were likely solitary, not because they preferred isolation, but because they no longer depended on safety in numbers. And maintaining a body like that required something just as remarkable, because strength on that scale comes at a cost. To understand how this prehistoric creature maintained such power, we must look at how it fed and how its body processed the world around it. And that strength began with its armor. Across the back and sides of Ankylosaurus magniventris were bony plates known as osteoderms. These were not just rigid blocks of bone. They were shaped and arranged in a way that helped spread the force of an impact across the body. Some were rounded, others flatter, forming a layered protective surface. Beneath them, dense connective tissue, including collagen, likely helped absorb shock and reduce damage. This was not just armor designed to resist force. It was built to manage it. Its body reinforced that defense. Low to the ground, wide through the torso. With a center of gravity close to the earth, it was extremely difficult to knock over. For predators, that mattered, because exposing the underside of prey is often the key to a successful attack, and Ankylosaurus made that nearly impossible. Still, it is important to be precise. This animal was not invincible. Its armor was not bulletproof in the modern sense. But its structure strongly suggests it could withstand powerful bites and impacts better than most animals of its time. Maintaining a body like this required constant energy. An adult likely consumed around 130 pounds of vegetation each day. It fed low to the ground, cropping ferns, shrubs, and other soft plants. Its beak stripped vegetation efficiently, while its small, ridged teeth helped break it into smaller pieces. Inside the body, digestion was slow and deliberate. Like many large herbivores, it likely relied on hindgut fermentation. Bacteria helped break down tough plant fibers, extracting nutrients over time. This process required space, which helps explain its wide abdomen. Its sense of smell was likely well developed, helping it detect food and potential danger. However, compared to others, its eyesight was poorer, and its movement was slow, probably no faster than a steady human walking pace. But it did not need speed, because it lived in a world where survival did not always depend on escape.
Of the lowlands.
That world was the late Cretaceous landscape of the Hell Creek Formation, a region of rivers, floodplains, and dense vegetation. Warm, humid, and full of life. Here, Ankylosaurus lived alongside some of the most well-known dinosaurs. Massive herbivores like Triceratops moved through the landscape, feeding on tougher plants. Herds of Edmontosaurus grazed in open areas, relying on numbers for safety. And nearby was Tyrannosaurus rex, a predator capable of taking down large prey. Smaller hunters were present as well. Dromaeosaurs moved quickly through the undergrowth. Crocodile-like reptiles waited near the water's edge. But Ankylosaurus followed a different path. It endured for millions of years. Yet despite its massive size and incredible strength, Ankylosaurus left behind surprisingly little evidence.
Bounty.
While it was likely not rare in its environment, its fossils are exceptionally scarce, making it one of the rarest large dinosaurs in the Hell Creek Formation. So why is the ultimate survivor so hard to find? Ankylosaurus magniventris is almost invisible in the fossil record. In the largest survey of the Hell Creek Formation, scientists found something striking. Out of all large dinosaur fossils collected, Ankylosaurus made up only about 1%. To put that into perspective, Triceratops accounted for roughly 40%, Tyrannosaurus rex about 24%, and Edmontosaurus close to 20%. Ankylosaurus, just 1%. In some datasets, that amounts to only a handful of large specimens, and it gets even more unusual. To this day, no fully complete skeleton of Ankylosaurus has ever been found. What we have are fragments, partial skeletons, a few skulls, scattered armor plates, isolated teeth, but never a complete animal. So why is that? Was it truly that rare? Or is something else shaping the story we see today? There are two likely answers. The first is ecological. Ankylosaurus may have been naturally uncommon. Not every species dominates its environment. Some exist in smaller numbers, filling very specific roles. The second explanation lies in how fossils form, a process known as taphonomy. Most fossils come from low-lying environments, floodplains, riverbanks, wetlands, places where sediment can quickly bury a body before it decays or is scattered. But Ankylosaurus may not have lived there as often. Evidence suggests it spent more time in upland environments, higher, drier ground. And in those places, death rarely leads to preservation. Bodies are exposed, broken apart, carried away, long before they have any chance to become fossils. This creates what scientists call a preservation bias, a record shaped not by what was most common, but by what had the best chance to survive burial.
Ankylosaurus magniventris.
So the picture we see today may be incomplete, not because Ankylosaurus was unimportant, but because its world did not preserve it very well. All of which leads to a quiet but powerful idea. One of the most heavily armored animals of its time may also be one of the most elusive. Even the strongest armor cannot protect a species from the passage of time. For millions of years, Ankylosaurus magniventris endured. It survived predators. It survived competition. It survived a world filled with danger. But around 66 million years ago, That world changed in an instant. An asteroid struck what is now the Yucatan Peninsula, an event we now call the Chicxulub impact. The impact released more energy than billions of nuclear weapons. Fires spread across continents. Dust and debris filled the atmosphere, blocking sunlight for months, perhaps years. Plants began to die, and with them, the entire food chain began to collapse. And in that moment, even the most heavily armored animal of its time had no defense. The story of the prehistoric creature that once terrified the T-Rex, just like so many other stories before it, has come to a close. In the next video, which prehistoric creature do you want me to explore? Please comment below and don't forget to press the subscribe button so you don't miss the most fascinating information. Thank you for watching.